All right, for this one, they told you in the instructions, find the exact value of the expression in terms of x with the help of a reference triangle. So, starting inside of the function, we know that the sine of some angle is equal to x minus 1. So this is where the triangle comes in. So we draw a triangle. Here's our angle. Sine, the formula for that is opposite over hypotenuse. So we're going to take this number that's not a fraction and make it into a fraction by putting it over 1. So the opposite side is x minus 1 and the hypotenuse is 1. They want to know the tangent of this triangle. The tangent of the triangle is the opposite over the adjacent. So the opposite side is x minus 1. We don't know the adjacent side, but just like every other time, we can find it by doing the Pythagorean theorem. A squared plus b squared equals c squared. So we have a squared plus b squared equals c squared. We're going to square the x minus 1. Remember, that means x minus 1 times x minus 1. You might have to stop the video here to see how I got that by writing it all out and foiling it. And then we're going to solve for a because they want this in terms of a here. That's what we're solving for. So we're going to move the 1 over, which is going to cancel the 1's out when we subtract. We're going to move the x squared over. We're going to move the 2x over. So a squared is going to equal negative x squared plus 2x. Then we're going to take the square root. I know it looks gross, but that's okay. So then that's going to go right here. That's what the adjacent side is. And so then that's going to go here. And I'm going to have to double check in the back of the book to see if they rationalize that denominator. Sometimes if it's really a gross denominator, they won't rationalize it. So let me flip back there and check. 37, 6, 3, 37. Oh, they just left it like that. So that was your final answer. That's the tangent. The opposite leg over the adjacent leg. All right, the next couple are story problems. This one right here tells me that you have a 13-foot ladder leaning against a house. It reaches 12 feet up the house, and they want to know what is the angle in radians does the ladder make with the building. So here's my ladder, here's my building. There's the angle they're asking about. So we have the adjacent and we have the hypotenuse. The formula for adjacent and hypotenuse is cosine. So we're going to plug in the information we know, which is 12 over 13. We're going to move cosine over. So to move cosine over, we have to do the inverse cosine. They want this in radians. So we're going to make sure our calculator is in radians, which it was from the last video. And then we're going to do the inverse cosine. So second cosine. And then 12 divided by 13. And you get 0.395. The next one in this section that you asked about was 55. In 55, they told me that you had an isosceles triangle. It has two congruent sides. Obviously, it's isosceles. Those are equal to 9 inches, and then the other side is 8 inches. They want to know this angle, the angle that the 9-inch makes with a 8-inch. Well, first of all, we need a right triangle here. This is not a right triangle, so I'm going to draw in a height of the triangle. Now, this is a special case. When we create this right triangle here, what ends up happening, we're looking for this angle. Remember that this was 9. This actually bisects this side in a isosceles triangle. So this is going to cut this side down to 4 inches. And again, they're looking for this angle. So we look at the sides we have here. We have adjacent and hypotenuse. So it's going to be the cosine of theta equals adjacent over hypotenuse. So the cosine of theta equals adjacent over hypotenuse. And it doesn't tell me to use radians or degrees, but I'm going to assume we want this in radians. Again, we need to move cosine to the other side. No, you can't divide by cosine. Cosine isn't attached to theta by multiplication. We have to do the inverse of cosine. That's how you move things from one side of the equation to the other, is by doing inverse operations. And division is not the inverse of a cosine. And we get 1.11. So theta equals 1.11 radians. And then the last one says you have a line y equals negative 3x, passes through the origin in the xy plane. So I graphed that. This is the line y equals negative 3/7x. So this is the line, has a slope of negative 3/7, goes through the origin. They want to know this angle right there. Well, that angle right there is the same as this angle right here. And notice here, we have this beautiful right triangle, whose side here is 7, and whose side here is 3. So if we wanted to find this angle, we have the opposite leg and the adjacent leg, which is tangent. So we have the tangent of some angle is 3/7. Move tangent over by doing the inverse tangent. So we go to our calculator, do the inverse tangent of 3 divided by 7, and you get 0.40. And that was the last one.